The DNA sequence shown below is one that was given. If we want to find the strain that codes for 5 amino acids, we would make the top strain the template strain. This makes the bottom strain the coding strain. During transcription, the DNA would get read from 3' to 5' to produce mRNA from 3' to 5'. The best way to figure out the mRNA strand is to rewrite the coding strain of the DNA from 5' to 3' and change all of the T's to U's, or in other words, all of the thymine bases to uracil bases. To translate the mRNA into a sequence of amino acids, you need to find the start codon, or AUG, which codes for methionine. Then, every codon is read until a stop codon is hit. This stop codon does not become an amino acid, so is not part of the chain. One point mutation that can occur is a missense mutation. This mutation changes an amino acid. If we change the G on the original DNA to a C on the new DNA, this would cause the mRNA to code for a serine instead of an arginine. Since this change is from a purine to a pyrimidine, this would be a transversion. Another point mutation that can occur is a nonsense mutation. This mutation changes the codon so that it becomes a stop codon. If we change the A in the original DNA to a T in the new DNA, this would cause the amino acid chain to be shorter and therefore different than the original amino acid chain. Since the A got changed to a T, this would be a transversion since it is a purine to a pyrimidine. Another point mutation is the silent mutation. This mutation changes the codon, but it does not change what amino acid the codon codes for, so the amino acid would be the same. If we change the C up here to a T, the protein sequence would still be met-val, just like the original sequence. This would be a transition, since the C changes to a T, or a pyrimidine to a pyrimidine. The last point mutation is a readthrough mutation. This mutation changes the stop codon to a codon that codes for an amino acid, resulting in a longer amino acid chain. If the T here in the original DNA sequence is changed to a D in the new sequence, the codon changes to GAA, which codes for glue, instead of a stop codon. I think of a stop codon like a stoplight on red. If it is red, the sequence has to stop. If the stoplight changes to green, like it did here, the sequence has to continue. Since the mutation was from a T to a G, or a pyrimidine to a purine, this was a transversion.